morning, everyone. It is March 7th, Monday, March 7th. We're holding, it is now Hey Adar. We're on the fifth day of Adar. The first day was Friday. And as we continue into the month of Adar, this topsy-turvy weather pattern continues across our country and even across the world. If you look I saw certain spots which are getting unbelievable amounts of snow. Some areas close to the Ukraine, some areas by Japan. They're just getting really enormous amounts, but I'm not going to specify those areas for right now. Let's just go right into this country. There's plenty to talk about here in the country. Right now we have a low pressure system that's moved across the Midwest, moved into the Ohio Valley, and it's up into the Northeast. This system brought probably between 1 and 6 inches of snow, about 3 inches of snow here in the Chicago area. From the maps that I saw, about 2.9 inches. We also had really the more impactful weather that this storm system brought was the tremendous tornadoes. 30-some tornadoes hit the Iowa area, really magnificent stuff. And we also saw some 70-mile-per-hour wind gusts, perhaps even stronger. Here in the Chicago metro area, we also saw some very strong wind. That was on Motzei Shabbos here. Winds were really probably some of the strongest storms that we've seen in a number of years here in Chicago. We have the background noise, of course. We love to have that background noise of the storms. Now, today we saw unseasonably warm temperatures once again. Record warmth was recorded over in many locations. We'll, Yirtzeh Hashem, have more details in regards to that later in the week. The frequency of the podcast, I noticed that the more frequent, the more consistent and continuous this podcast is given, the more followers there are. We have the top 3 countries in general have been Russia, India, and America. In general, those are the top 3 countries that are listening to this podcast. And Russia has kind of fell off a little bit recently. So we're in India and here in the United States. Those numbers go up. It's when it's more consistent. So it's not necessarily there's really any chidushim that are going to be said in regards to the updates, but nonetheless, there's chidushim in the passion as to what's going to be going on and probably some more clarity over here. We have high humidity that was seen across the south and the southeast. Temperatures once again went into the low 90s for parts of Florida, areas to our southeast. We had really warm temperatures once again in the mid-Atlantic area. It's certainly reasonable to believe that places went up into the 80s, all the way up into the mid-Atlantic area. It would be very interesting to see exactly which counties and how far north temperatures actually did make it into the 80s. Severe thunderstorms right now are a good possibility over in Baltimore and over much of the New York area. And we're seeing over there as well the possibility for 60 to 70 mile-per-hour wind gusts. But the big story for this week, for the next several days for here in the Chicago area, is this upcoming storm system that's going to be developing Wednesday night through Thursday night. This low pressure system developing off into the desert southwest. That system moves and kind of falls apart, but then redevelops over in the Oklahoma area as a surface low, as these things usually do. And at the same time, we have a Vort Max coming out of the Arctic, which we're not going to get into that right now. Is exactly the difference between a Vort Low and a Vort Max, perhaps at a later podcast. But we will briefly mention there's a shortwave coming out of Alaska. Now, the shortwave, the way I understand it, is that it's a pocket of cold air in the upper atmosphere. What this does, other people refer to this not as a shortwave. Some people call it an impulse. Other people just call it a piece of energy. And if you've noticed, a lot of the storms, the low pressure systems that develop here in the Midwest that bring the heavy snow, you'll notice a lot of times that they mention there's a piece of energy, some type of an impulse that's also coming, and also this Arctic air, they all have to come and collide, and the Gulf moisture comes as well. The Gulf moisture is something that is just a given this time of the year. We're already holding in March. We've seen those dew points. Actually, according to some of the dew point maps yesterday, we saw dew points go into the 70s. I couldn't find any city in particular with a dew point in the 70s. Dew points seem to be about 69 and 68. I'm sure the 70-degree dew points existed. And I'm referring to Texas, not Florida. Florida could very easily have had dew points in the 70s. That doesn't have as much meaning as if Texas has dew points in the 70s. And even Texas, that doesn't have the same meaning as Oklahoma or Arkansas, places like that. we have these different variables which are expected to come together right here in the United States. What's unique about this, I always try to find the unique aspect to each storm. Recently, I've been trying to do that. And what's unique about this is the intensity of each of these ingredients because of the month of March. The Arctic air, we're dealing with heavy-duty Arctic air. Nothing record-breaking for us. Nothing record-breaking, and it's going to be short-lived, very short-lived. As of now, we're expected to see a moderation in temperatures shortly after it comes, but this is, it's still winter, especially in the Arctic, and that air comes down here. Then we have also the hot and humid air coming down from the south as if it's summer momish. So those two things are coming together, and we have that thing in Alaska. I would imagine the fact that this shortwave, this impulse, this piece of energy is developing along a Pacific ridge. I think there is significance to it. What exactly the significance is to that, what type of punch is that going to put into this upcoming storm system, I will have to work on that more. But we do have a low pressure system, and what's something which is exciting about this one is the fact that it has a clear pressure. It's a clear pressure, a clear track. Even on the, you look at the computer models on the Windy app and you see it. It's as if you're looking at an East Coast storm. It's not 100% as if you're looking at an East Coast storm. Therefore, in order to have a clear idea of exactly where the low pressure system is, sometimes I like to go into the winds into the upper atmosphere. And I was shocked to see that when you go into those winds in the upper atmosphere, some of these systems, it actually looks like it's a hurricane. It actually looks like there's an eye. And I was wondering, is it an eye or is it not an eye? EYE, an eye to the hurricane. So I put the little thing to determine what the wind was right in the middle, and the wind was 1 mile per hour, and the winds are much stronger outside of that. So it does look like a strong storm system. The GFS model, for some reason, happens to match up very well with the winds on that Windy app. The European computer model in general does a better job at forecasting. The winds don't match up, and I don't know why that is. I don't know why the winds don't match up to the low pressure. Low pressure, again, the air around low pressure goes counterclockwise, and the winds, the counterclockwise winds with the center is not in the same spot as the low pressure is when you look at the European computer model, but by the GFS model, that's a different story. The German computer model is expected to be, I believe that's the one that's the most accurate. It's either that one or the Switzerland one that's the most accurate when it comes to temperatures and for winds. But storm systems, the European computer model is just unbelievable. It does a fantastic job. We also have the North American mesoscale model. That one has higher resolution, and there's a good possibility that the higher confidence in forecasts don't occur until 3 days before the event, because that computer model only goes 3 days out. So the European computer model goes 2 weeks out. What's fascinating about this system is there's enormous consistency. This is not normal. There's enormous consistency between the GFS model and the European computer model, especially for Chicago. If you live in Springfield, Missouri, there's not. In Springfield, Missouri, you have one of the models shows snow, the other model shows no snow. But we do see that conditions are cold according to both models. The cold air is going all the way down into Texas. Chicago is getting snow either way. There might be a difference of an hour as to when that snow starts and as to when exactly the snow ends. Total storm accumulations, I always like to say that when we're dealing with a Midwest storm, total storm accumulations in the bullseye tend to be 6 to 12 inches, 3 to 6 inches outside of that. Generally, Chicago ends up not in the bullseye, but in the thing closest to the bullseye. This particular system, as of now, they are forecasting the bullseye to be 3 to 6 inches, which puts Chicago at 1 to 3. But if you wanted to come out with the real AccuWeather forecast, not the way they're wording it professionally to the public. They're wording it professionally to the public as 1 to 3 inches. But if you look at the 1 to 3 inches, they provide an enormous amount of information about their forecasts, unlike any other forecast. And they tell you the chances of that happening are only 50%, if even that. The general rule is, if something does not have an 80% chance of happening, you cannot expect it. It remains in jeopardy, whether that's going to happen or not. So you have the highest chance of anything happening is 1 to 3. But in order to get an accurate forecast, you're going to have to add the inches, the category above the 1 to 3, and you're going to have to add the category below the 1 to 3. Each one has a 17% chance of happening. Now, when you get that, you end up with past 80%. So you have a dusting up to 6 inches. That would be the most accurate forecast right now. The chances are highest right now that we would fall within the 1 to 3, but a most accurate forecast would be not to focus on sounding professional, but to focus on accuracy. What is the emes over here? What is actually being forecasted? And if there's only 50% confidence in 1 to 3, that's not really what's being forecasted. That means maybe yes, maybe no. So we have to add the dusting to 6 inches. We're using the tools of AccuWeather to do that. Okay, that's one way to do this. It sounds reasonable. The one thing that's disappointing to me in regards to this upcoming storm is the fact that it is positively tilted and it's not negatively tilted. Now, I could explain that, but I want to reserve the explanation for that for a time when I can explain it even better. But I'll say one thing, is that when it's negatively tilted, the winds are more directly from the south ahead of it, and the system has more energy to work with. The temperatures are warmer. There's a lot more going on with the system. A lot of times, however, systems which start off with a positive tilt end up with a negative tilt. When you look at how intense this low pressure is eventually going to become, according to the European computer model, even the GFS, but the GFS doesn't have, it's not quite as intense according to the GFS as the European computer model. And then at the end, not only is it expected to become intense, but it's expected to intense rapidly to the pace of abomagenesis, which is when it drops 1 millibar every hour. Drops 24 millibars within 24 hours, probably equivalent to dropping like a 0.7 in the inches of mercury. It would be like going from like a 29.6 to a 28.9 within 24 hours. That's roughly what I would say on the top of my head, something like that. So it's going to be doing that. So one would have to assume something like that generally has a negative tilt, according to what I understand. We're going to go back for a moment and just talk about why a pocket of cold air would add a lot of energy into the upper atmosphere. And it's like this. When you have an air temperature, let's say the air temperature is 85 degrees on the surface. So for every 4,000 feet it goes up, the temperature drops 22 degrees. So that means you go up 4,000 feet into the atmosphere, that 85 degrees is now 63 degrees. The dew point, a common dew point when temperatures are 85 in this part of the country in the summertime or outside of the cornfields and in between, let's say the Gulf, or let's say in the springtime, it would be a dew point of 65. That's a normal dew point. So now what happens is the dew point stays the same. The temperature drops as you go up. The temperature drops. The reason the temperature drops is because the air, as it goes up, the air molecules run into less density air, and as a result, the air molecules expand. When the molecules expand, that expansion requires energy, and when the molecule gives off energy, it loses its heat. So the temperature drops, and a standard drop again. It's 5.5 degrees Fahrenheit for every 1,000 feet you go up. So you go up 4,000 feet, we're talking about 22 degrees. The amount of water vapor in the air stays the same. Now this is how the clouds form. You go up 4,000 feet. Once you're reaching a point where the temperature has dropped to the dew point, sometimes that forms clouds. Sometimes you can get clouds even before the temperature drops to the dew point. Usually, however, the National Weather Service reports that the point of saturation actually has to be a little bit more saturated than saturated before the real clouds start to form. So now, keeping that in mind, we go on to discuss what it means to have an unstable environment, or an environment with a lot of lift. When there's a lot of lift that has a lot of energy, and that helps produce the rain or the snow. So what has to happen is you have to have the air outside. The air outside of this molecule that's going up into the atmosphere has to be dropping. This is called the lapse rate. I think I'm giving more of a shear here, more of a lesson than a passionate forecast here. But it's about time we explain some of this. The lapse rate, this is stuff that comes up in the forecast discussion all the time from the National Weather Service. The lapse rate is the rate at which the temperature decreases as it goes up. So we explained as it goes up, it goes into air that's less dense. That air molecule expands, and when it expands, that requires energy to do so. And the release of that energy is what causes the temperature to drop. Now, as long as that temperature in the air molecule is warmer than the air around it, it's going to rise. So if we should get a pocket of cold air, what seemingly they call a shortwave impulse, there's probably a lot more that goes into it than that, but shortwave impulses have been nicknamed pockets of cold air or pieces of energy. That's probably the best way to present it to the public. But so when you have a pocket of much colder air that pops up, this thing's coming from Alaska, so then these air molecules rise very quickly. That reduces the pressure even more, and that increases the precipitation. So sometimes you could have plenty moisture in the clouds, but that's not going to cause it to produce any precipitation. There's a lot more that goes on, but this is something that meteorologists are looking out for to see. There's a number of different terms that these things are called. For right now, we're just going to call it could produce instability, and it also produces a lot of lift. And when you get a lot of lift, that's when the snowfall, the precipitation rates tend to be heaviest. We're going to have tons of moisture coming in off the Gulf of Mexico. I don't know how much, but it's just so obvious when you look at these weather maps and you see the wind just pouring off of the Gulf of Mexico. This is especially true for the East Coast. So we have that. If that shortwave gets here in time, then we have that lift. To point out one other thing, however, is that even if the shortwave doesn't get here in time, Chicago, I would imagine Lake Michigan, has the ability to produce just a natural shortwave. We'll have to look into that to see how true that is. By the last system, we had a little bit of a mesoscale that developed right outside Porter County. A mesoscale is like a miniature storm system that formed actually not in Porter County. It was right outside Porter County on Lake Michigan. So we go ahead, we look at the storm. Again, the disappointment here is the fact that it's not a negative tilt, at least not now, and at least not as it's forecast to be here in the Midwest. But there's other parts to the storm that are just really cool. The fact that we finally have a solid system that on the maps you could actually see that the low pressure reflects what they are saying, whereas up until now you have to rely upon the gradient, which means the relative. It's not that the low pressure itself that was strong, but it's the fact that the low pressure was surrounded by such high pressure that produced the low pressure had more strength to it than what an ordinary 29.6 would have, or even a 29.8. It was as if the 29.8 was a 29.5. The general call is, however, that if you can get a 29.2, that's when you get a foot of snow, says the expert forecasters of AccuWeather. That's when you could have the right to forecast a foot of snow in the bullseye. And a foot of snow means 12 to 18 inches from my understanding. That's on the East Coast. This storm system is expected to intensify rapidly, go well beyond 29.2. It's, in fact, according to one of the models, European model, the most accurate model, it's eventually going to be dropping below 29, and I think it's even going to get lower than that. So, but that's a little bit as it gets further out from there. Now, we have to deal with the amount of snow that's going to be falling here in the Chicago area. Again, we're going to rely upon the professional forecasters that have an enormous amount of information before them. That puts us at 1 to 6. Climatology would put us at 3 to 6. They're actually forecasting 1 to 3. Moving on to the East Coast. This is a dynamic storm. that's moving up the East Coast. Currently, the European computer model has this again as a very intense storm. I just want to reiterate, here in the Midwest, for the Chicago area, we're very lucky. Both the GFS model and the European computer model have a lot of consistency for the Chicago area and areas around the Chicago area. There's also consistency in Texas. It's the area in between Texas and Chicago where there's inconsistency. Okay, which one's going to be right? We don't know. The European computer model, I think, tends to be right, but GFS model apparently has mamashes to it, and there's things that we have to take out from the GFS model in order to make a truly accurate forecast. So, by the East Coast, however, they do not match up. There is a difference between the GFS model. It does not have this system organizing in the same way as the European computer model. But the one thing that is consistent is that both models are taking these storm tracks along the coast or even a little bit further inland. That means the inland locations at this point probably will not be getting any significant snow. The significant snow will be staying much further inland. The GFS has us going even further inland than the European computer model. Now, for weather enthusiasts, for winter weather enthusiasts, this is, we're coming to the end of the winter. Many of us, these storms determine mamish the pulse of our heart. This is something that we look forward to every single year. And we have some other weather favorites that occur during different seasons. During winter storms is really the par. I mean, that's really way up there. Nothing could be greater than that. And we're coming to an end. We have seen strong storms in April. We have seen that happen before. But we're holding in March, and we have the potential for something to happen this Thursday night, Friday night, and Shabbos. Those of us whose very pulse is dependent to a certain extent on these winter storms should pay attention to every detail, every update, everything, because again, there's enormous potential regardless of whether it's a positive tilt or a negative tilt. Here in the Midwest, one thing we have to realize, the sun is a powerhouse right now, a total powerhouse. For all essential purposes, we have tropical sunshine here in the Chicago area. The ultraviolet index is way up there. And I think this podcast is going to be titled For Weather Buffs Only, because this contained a lot of information which the general public might not be interested in. I hope to do another podcast, which will be a summary of this one that will focus maybe more on some of the practicalities, the excitement, the real excitement, without understanding the lumdus. Anyways, thank you for listening. What goes on between now and Thursday is not significant to me, and therefore I do not spend much time in it. Whatever your local forecasts say, that's what it's going to be. And I think Thursday, Friday, and Shabbos, those are the days to look into. The Chicago area, according to some models, still have snow in our area, even 8 a.m. Shabbos morning. And again, this time of the year, whatever is going to fall at night, that's the stuff that's really going to accumulate during the day. We have tropical sun over here. People are encouraged to use sunblock lotion. The sun is strong. It's really strong. The sun is high up in the air. We're getting ultraviolet index, I would imagine, is a 5. I would have to look it up to see, but it's really, really much stronger than what it was. Already in the end of January, it was easily detectable that we're dealing with a much stronger sun, and we're already holding in March. And it's a losing battle. Those of us that love the snow, it's a losing battle. We do have some phenomenal stuff going on in the polar vortex, which might affect the area. I have reason to believe that it might affect parts of this country with a snowstorm during the 3rd week of March. So people could pay attention to that. But for now, following the storm of next weekend, we're going to get a one-day blast of very cold air. Then the temperatures moderate after that. I wish everybody a great day. Thank you for listening.